has offered its very new engineering course, the Robotics Engineering. This engineering discipline focuses on designing, testing, and building robots. Robotics engineers are the creative minds behind the interdisciplinary research area at the interface of computer science and engineering.
2 years ago, ADDU has also offered its recent engineering course, the Aerospace Engineering. Aerospace engineering deals with the design, development, construction, testing, and operation of vehicles operating in the Earth's atmosphere or in outer space.
ADDU has not only enriched its students with quality education and instruction, but it has also inculcated Jesuit ideals and formed
The future leaders of the society.
The future men and women for others.
and stewards of the environment.
Tara! At samahan kami sa paglalakbay na ito. Opportunities in engineering and architecture are limitless and fulfilling.
In pursuit
Opportunities in engineering and architecture are limitless and fulfilling.
In pursuit of providing quality education, robust research at NEO's School of Engineering and Architecture has proven itself to excel not only now but in
School top across different course offerings, and it
We'll be starting in a few minutes.
toppers across its different course offerings, and it has consistently placed as one of the top engineering and architecture schools in the Philippines.
Architecture is the art, science, or profession of planning, designing, and constructing buildings, taking into account their environment in accordance with the principles of utility, strength, and beauty.
The program covers five essential civil engineering fields, which are structural, transportation, water resources, and geotechnical engineering, and construction engineering and management.
Chemical engineers conceive and design processes to produce, transform, and transport materials, from lab experimentation to full-scale production.
The program is a combination of computer science and electronics engineering, which allows engineers to have a strong skill set and understanding of both computer system hardware and software.
Electronics engineering focuses on the conceptualization, design, and implementation of new electronic, computer, and communication products, systems, and processes.
This engineering discipline deals with the design, development, and application of equipment that utilizes electricity, electronics, and electromagnetism.
Industrial engineering gives undergraduates key notions about the design, planning, and optimization of production and manufacturing processes.
This engineering discipline focuses on the design, planning, and manufacturing of individual parts and pieces to gadgets and large machines or systems.
But improvements are still yet to be seen, and this year, ADDU has offered its very new engineering course, the Robotics Engineering. This engineering discipline focuses on designing, testing, and building robots. Robotics engineers are the creative minds behind the interdisciplinary research area at the interface of computer science and engineering.
2 years ago, ADDU has also offered its recent engineering course, the Aerospace Engineering. Aerospace engineering deals with the design, development, construction, testing, and operation of vehicles operating in the Earth's atmosphere or in outer space.
ADDU has not only enriched its students with quality education and instruction, but it has also inculcated Jesuit ideals and formed
The future leaders of the society.
The future men and women for others.
and stewards of the environment.
Tara,
at samahan kami sa paglalakbay na ito.
So that was a preview of the career, the different courses here in School of Engineering and Architecture of Ateneo de Davao University. To formally start the program for today, we'll be having our invocation first.
Busa ikaw lang ang simbahon ko.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم فقال ربكم ادعوني أستجب لكم آمين يا رب العالمين الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين آمين اللهم اجمع شمل المسلمين والكريستيان والأمة في مدينة دباو وسلم دائما مجتمعنا هذا بالسلم والأمن والتقدم في بلدنا هذا آمين يا رب العالمين ربنا لا تزغ قلوبنا بعد إذ هديتنا وهب لنا من لدنك رحمة إنك أنت الوهاب ربنا إنك أنت الوهاب ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار وصلى الله على خير خلقه سيدنا محمد وعلى آله وصحبه وسلم سبحان ربك رب العزة عما يصفون وسلام على المرسلين والحمد لله رب العالمين آمين يا رب العالمين.
In the name of the Father, Son, and Holy Spirit. Amen. Our most gracious Heavenly Father, we come to you today to praise and worship you and give you thanks for all the things you continue to provide for ourselves and our families. Father, we humbly ask for forgiveness for all the times we have offended you. When we forget to acknowledge your presence in the image of our brothers and sisters, and for moments we fail to be good stewards of the blessings you have given us. Continue to guide and protect each one of us, Lord, that we may always walk in the light of your everlasting love and mercy. Grant us, Father, with your comfort in times of distress and with your strength in times of weakness. Bestow upon us your unending grace and healing, that we may in turn become instruments of gentleness and compassion to others. We ask all this in the name of your Son, our Lord Jesus Christ, with the prayer and the intercession of our Blessed Mother. Amen.
Manama, mawantog ka. Warag po ko ilingkod ko. O Diyos, kahibulungan ka. Busa ikaw lang ang simbahon ko. Busa ikaw lang ang alagaran ko.
So again, good morning everyone, and welcome to the ADDU Davao University School of Engineering and Architecture Career Day. So to formally welcome us, may I request Dr. Renil Baroca, the Assistant Dean of the School of Engineering and Architecture, to give his opening remarks.
To the Dean of the School of Engineering and Architecture, Dr. Randall Espina, Ms. Ojipel Amor Lee, the Assistant Director for Academics of the Senior High School, Mr. Bonimar Mahilum, Grade 12 STEM Chairperson, Mr. Orville Ibardo Jr., the Engineering and Architecture and Calculus Cluster Leader, the academic administrators and faculty members of the SEA, to the senior high school student under the pre-engineering track, the future members of the SEA family. A pleasant morning to all of you. Welcome to this virtual orientation on the different programs of the SEA. This activity actually aims to introduce the 10 programs. So we have 10 programs in the SEA, namely the architecture, the aerospace engineering, the chemical engineering, the civil engineering, the computer engineering, electrical engineering, electronics engineering, industrial engineering, mechanical engineering, and the newest program, no, which is the robotics engineering. The details of these programs will be discussed later, no, by each of the department heads. And then if you have questions in your mind, you may raise it during the open forum, and we will gladly provide you with the answers. And to keep everyone abreast with the latest trend on technology and engineering, an input on the fourth industrial revolution, or what we call the IR 4.0, will be delivered by our dean, Dr. Randall Espina. I enjoin everyone to pay special attention to this because knowledge on IR 4.0 is relevant to all disciplines. We hope that you can pick something for inspiration as you navigate your way towards the completion of your schoolwork now and towards achieving your final decision regarding your respective careers. I am very happy seeing you all today. I know most of you, if not all, are excited and at the same time feeling uncertain. Excited to discover the new world of the college life that awaits you, and uncertain of what career path you are going to pursue. There are a lot of things that you will come across in the coming days, or coming weeks, or coming months, no, in making your decision. So, having been there, my advice for you is to just follow your heart, and don't forget to ask advice from your parents, your elder siblings, your elder friends, and of course your teachers. And if you happen to choose to be with us in the next semester, I assure you the quality of your education is our highest priority because we believe that you are the key players of the society in the future. We are working very hard to attract and keep high caliber faculty members in continuously developing globally relevant curricula and in providing individual attention to the progress of each of our students. So once again, welcome everyone and good morning.
Thank you so much, Dr. Baroka. Dr. Baroka was right. So this is today, you students, you learners will be realizing your future career path, especially here in the ADDU School of Engineering and Architecture. Well, now, to break the ice, we'll be having mini games. So first, we'll be having the hashtag mechanics. We'll be posting the hashtag mechanics, and you will be getting prizes from this. So you can win a special prize by joining the hashtag mania. So the mechanics will be first, like the Facebook pages of ADDU SHS Robotics and ADDU School of Engineering and Architecture. So it will be facebook.com engineering archi and facebook.com ADDU SHS Robotics. Second is to post a picture of you that resembles the person you aspire to be. This can be posted on either Twitter or Facebook platform. Then caption it with your takeaways from the webinar with hashtags hashtag ADDU Career Day, hashtag Industry Rev Up, and hashtag Fun with Robots. And lastly, tag a friend to share the learnings and make sure the post is in public so it can be acknowledged. The winner with the most brilliant caption and picture will be announced at the end of the webinar. So stay tuned at the end of the webinar to win prizes. Okay? So after this hashtag, we'll be having another game, which will be a 4 picks 1 word. This is a 4 picks 1 word EA edition, or Engineering and Architecture edition. So again, we still have prizes, more prizes for today's webinar. So for the mechanics of the game, each presentation displays 4 pictures linked by 1 word, just like the same mobile game. The player's aim is to work out what the word is from a set of blank lines given below the pictures. The fastest player to type his or her correct answer in the Zoom chat box wins the game. Do note that only the participants inside the Zoom meeting can win the prizes. and the winner will be identified immediately after each presentation. So to claim your prize, kindly email your GCash number to Engineer Montani at obmontanijr@adu.edu.ph. So can we start now? Are you guys ready? So you will win GCash prizes for this if you get or you answer correctly. You will be the first one to answer correctly. So make sure that your fingers are ready, your keyboards are ready, and make sure to open the chat box. Okay, now let's have the first item. I think we'll go to the second one. That one. So there will be 30 seconds. Okay, time is up. May we know from the technical team who got the correct answer? So the winner is Avery Clyde Dimasuhid. The correct answer is calculus. So the motherboard earlier was just a preview, just an example para matestingan lang nato. Okay? So again, congratulations to Avery Clyde Dimasuhid. So kindly email Engineer Montani for your prize. Next, let's have the next item. 30 seconds. Three, two, and one. So time is up, guys. So who will be the winner for this item? And the winner is Renzo Isidore Malake. Congratulations. And the correct answer is blueprint. So kindly email Engineer Montani for your prize. Next item. 30 seconds starts now. Fifteen seconds. 4, 3, 2, and 1. And the correct answer for this number is plates. And the person who will win the prize is Victoria Ann Crisanto. Congratulations, Victoria Ann Crisanto. So that's it for the games for now. We'll have more games and prizes later. So at this point in time, we'll be having a talk on the power talk on the robotics engineering and industry 4.0. May I request the Dean of School of Engineering and Architecture, Dr. Randall U. Espina, to give us this power talk. Sir Randall?
Uh, Ked, ma- can you see my presentation or hindi pa siya nag-appear?
Yes, sir. We can see your presentation, sir.
Makita na, sorry Okay, so good morning, no? Sorry. So, Dr. Rinel Baroka, the chairpersons of the SEA, teachers, students, good morning. So, this morning I will present to you about the fourth industrial revolution in robotics engineering. And actually, I will also connect to other engineering in architecture programs of the university. So the fourth industrial revolution. Industrial revolution is an unpredictable and unprecedented transformation of socio-economic life. The industrial revolution is a process of quite substantial structural changes, which eventually ushered in accelerated economic growth. These changes are not simple economic changes in the government, social dynamics, culture, and political functions. So the mutual interplay among these changes shaped the process of industrialization and technological revolution. However, these changes cannot be analyzed without any reference to the class composition of any society, that is the British society, and the associated social tensions. The Industrial Revolution produced modern industrial capitalism. While the Industrial Revolution is benefiting the developed countries like the England or Britain or the USA, developing countries like the Philippines continue to lag and continue to suffer under development. So what is an industrial revolution? That is, when there are major changes in the industry, economy, that is the way we work, buy and sell things, transportation, the way we travel, society or social structure, the way we live. It is usually new ways of thinking and doing, and new technologies that cause the change to happen. England is the birthplace of the Industrial Revolution. In Britain's late 18th century, a handful of men brought about the most significant transformation in human society, powered by machinery in factory. They thereby changed human society, bringing new social and economic organization, new social classes, and new political forces. The Industrial Revolution also dramatically altered humanity's relation to the natural world and embedded the belief that change, not stasis, is the necessary backdrop of human existence. Industrial Revolution needed technological innovation to bring it into being. Some accounts of the period may imply that the innovations were less critical than the general increase in prosperity that preceded and, in their view, precipitated the Industrial Revolution. Before the start of the first Industrial Revolution, the architecture program was already a mature field. It even started in 2630 BC. In the first Industrial Revolution, also known actually as the Industrial Revolution, was the transition to new manufacturing processes in Europe and the United States, starting from about 1765 to 1784. And it was not accidental that the first Industrial Revolution took place in England. England possessed all the conditions required by the revolution, and it happened when they defeated the Armada the Spanish uh, groups, no? During the 1700s. In the 1780s, economic growth was found to increase by more than 2%. Actually, for more than a century, the economic growth was only about 2%. So that when it increased by 2%, we call it economic revolution, or they generally call it the industrial revolution. Hence, the 1783 to 1802 was considered the great watershed in modern society. The most significant changes came in the industries in mechanization, especially in the textile industry. Mechanization was the reason why the industry replaced agriculture as the backbone of the societal economy. Steam engines were first invented to provide power to the drainage pump in coal mines, but led to railway transportation. Massive coal extraction was done to run steam engines to speed up manufacturing and construction of railroads for transportation, and it accelerated economic mobility. And if you notice, during the first industrial revolution, mechanical engineering was introduced, and at the same time, civil engineering was introduced in 1835, or during the first industrial revolution. The second industrial revolution, also known as the technological revolution, was a rapid standardization and industrialization phase from the late 19th century into the early 20th century. The second industrial revolution started around 1840 to 1870, and it was during this revolution the internal combustion engine was developed. Other important points of the second industrial revolution were the development of steel, chemical synthesis, communication methods such as the telegraph and the telephone, the inventions of the automobile and the plane at the beginning of the 20th century are probably why the second industrial revolution was considered as the most essential industrial revolution. And during this time, electrical engineering, chemical engineering, and industrial engineering were born. In the third industrial revolution, which occurred in about 1969, it brought the rise of electronics, telecommunication, and computer. The third industrial revolution opened the doors to space expeditions, research, and biotechnology through the latest technologies. In the world of the industries, two significant inventions during the third industrial revolution was developed. They were actually the programmable logic controllers and robots that helped rise to an era of high-level automation. It was during this time that electronics engineering and computer engineering were born. In the fourth industrial revolution, it is actually the ongoing that is happening now. Maybe sooner we can have the fifth industrial revolution, but we still have the adoption of the traditional manufacturing and industrial practices using modern innovative technology. According to Klaus Schwab, it is characterized by a fusion of technologies that blur the lines between the physical, digital, and biological spheres. So I just put here about the robotics engineering and about aerospace engineering, though they started in about 1950s. But in robotics engineering now, we have the artificial intelligence. In aerospace, you have now new technologies to reach the sky and also to visit other planets. So these were the pioneering engineers and scientists during the first industrial revolution. It was actually Thomas Savery, in the 1650, an Englishman, an engineer, an inventor, who invented the steam pump. And also in 1704, we have the John Kay, an engineer and machinist who invented the flying shuttle. So actually the flying shuttle is being used for textile industry. Steam pump is basically for mining industry. After that, we have James Watt, Scottish English, a mechanical engineer, chemist, who developed steam engine. And after that, we also have Richard Trevithick in 1771, who was a British inventor and mining engineer who invented the first high-pressure steam engine. He also built the first working railway steam locomotive. So that was the start of the first industrial revolution with these industrialists, entrepreneurs, and actually as engineers. And during the second industrial revolution, these were also the pioneering engineers. Maybe you heard about George Westinghouse, no? Who is an American and actually an electrical engineer. But the first technology that he developed was about the railway air brake. No? Actually, he was working as an entrepreneur at the same time, an engineer during this time. And Thomas Edison, maybe you're already familiar about him. He's an American engineer, electrical engineer, who developed direct current. And he also developed about mass communication, sound recording, and motion pictures. And we have Tesla. We are familiar with Tesla because of Elon Musk. No? So Nikola Tesla is a Serbian-American inventor, or actually an Austrian-American, who is a mechanical engineer, an electrical engineer, and futurist, who is best known for his contributions to the modern alternating current electricity supply system, or the polyphase system. And we have Henry Ford, who is also an American engineer, actually an industrialist, no? And an entrepreneur who invented the quadricycle. No? During the time, he was thinking that there should be a new transportation mode, no, wherein people can afford. No? That's why he started with the quadricycle. Then eventually he developed the more advanced model, the Model T. No? Same thing that Elon Musk is now doing. You also have Alexander Graham Bell, the Wright brothers, and maybe you heard about Albert Einstein, no? And many pioneer engineers and scientists during this era, no, during the second industrial revolution. So going to the fourth industrial revolution. So what is happening, no? So as I said, the fourth industrial revolution is basically the convergence, no, of the physical, digital, and biological technologies. Because of the convergence of these technologies, no, the lives that we have is changing. No? The way we travel, the way we work, buy and sell things is now different compared to what happened even before the first industrial revolution. So these are the identified, no, frontier technologies in the fourth industrial revolution. First is the Internet of Things. I hope you're familiar with this. Then we have the smart sensors, advanced robotics, big data analytics, 3D printing, augmented reality, cloud computing, location detection, and many other technologies. No? That's why we are now probably moving to the fifth industrial revolution because of the new technologies that is also coming. So in the fourth industrial revolution, there were actually different definition or of the frontier technologies. We have the Organization for Economic Cooperation and Development, the World Bank, the World Economic Forum, the McKinsey Global Institute of Development Studies, and the MIT Technology Review. No? And if you notice, they have different technologies being locked into, no, for the fourth industrial revolution. But if you notice, for the red one, so we have the 5G, we have the Internet of Things, we have big data, we have robotics, we have automation, no? Many other technologies which actually is coming, no, during the fourth industrial revolution. And actually, there are no universally agreed frontier technologies. No? So as you notice, there's a lot of technologies, no, in the fourth industrial revolution. But the most common, no, frontier technologies that you can see, no, are the Internet of Things, 3D printing, and we have artificial intelligence. Hello, hello. Kid, madungog pa ba ko, Kid? Hello, Ken?
Yes, sir. Yes, sir.
Nawala man ganina, no? Sorry, ah.
Wala ko dali.
Sorry. So we have Internet of Things, no? Sorry. So actually, in one of my studies, no, at the University of California, I tried to develop the intelligent energy management system. This system actually is capable of monitoring and controlling your devices, no? So you would know the consumption anywhere, and at the same time, because I integrated artificial intelligence in the system, eventually the system will learn, no, how and where are you going to use electricity. So it will automatically turns on and turns off, no, because it is actually learning, no, what you are doing. And also in the 3D printing, no? So I think this is really an advanced technology. Currently, we can now hear, no, and about the house being 3D printed, no, a car being 3D printed, or maybe a heart or other organs, no, which are being 3D printed. And I think this will change everything, no, because in the future we can change, no, by simply 3D printing, no, everything, almost everything. That's why this is one of the frontier technology, no, in the fourth industrial revolution. In our case in Ateneo, actually in partnership also with Dr. Baroka and with some faculty in the School of Engineering, no? So we tried, no, designing a pico hydropower system because of the complexity of developing this one, no, using the machine device equipment, no? So machining devices. So we have to use 3D printer, no, to simply print, no, the device or the pico hydropower system. And maybe you heard about Lego Mindstorm. So we will love, no, Lego Mindstorm. We can play a lot. And maybe before we started the activity, there was a presentation about a competition on robotics using Lego Mindstorm. And on the right side, you can see Robonova AI. No? Actually, we have 2 units of this in the university. And you can, this is actually a humanoid robot. You can train this robot. You can ask this robot. You can allow this robot to move, no, autonomously, no, in a particular location. So, but the problem with AI in robotics is the creation of unemployment. So that's why we call this one as the ethical issues, no? We have actually identified 9. So what happens after the end of jobs? Inequality. How do we distribute the wealth created by machines? In humanity, how do machines affect our behavior and interaction? And artificial stupidity. How can we guard against mistakes? No? Racist robots. How do we eliminate AI bias? Security. How do we keep AI safe from adversaries? Evil genius. How do we protect against unintended consequences? Singularity. How do we stay in control of a complex intelligent systems? And the robot rights. No? How do we define the human treatment of AI in robots? So these are the impact and opportunities, no, and risks, no, of these new frontier technologies, which I identified only 3, no, IoT, 3D printing, and robotics and AI. So in economic, it will disrupt, no, traditional business models. Of course, no, you simply have to call Panda, no, to deliver. So it's really a big difference compared to even in 2010. No? And disruption of existing business processes. Maybe for civil engineers, you have to start thinking about this one, no? Where you only have to 3D print parts or the entire building, no? And it will change a lot, no? But what is the implication of robotics? It will really introduce technological unemployment, no? Maybe you heard about the news that eventually our our workers will be replaced by robots, no? And also income inequality and many other concerns about robotics and AI. So what we gonna do, no, to address this one? No? So we have to influence curriculum. We have to influence approaches to teaching and learning. So we have to introduce new skills and competencies. Because if we don't introduce this one, then we have a problem in this era. No? So I will now introduce to you about Bachelor of Science in Robotics Engineering, and I will try to connect this one to the fourth industrial revolution. So this is Sophia. No? Sophia was developed by Hanson Robotics, and it was activated on 14 February 2016. Actually, when I was in the US, this was also introduced in San Francisco. So And Sophia will be the robots of the future. So he's the first robot citizen, no, granted by Saudi Arabia. So what are the cognates or related programs in robotics? Basically, robotics is a combination or cognates, no, or convergence of multiple programs. One is computer science, computer engineering, electrical engineering, electronics engineering, industrial engineering, and mechanical engineering. Basically, in robotics, you have mechanization, automation, and artificial intelligence. So basically, a robot has 5 parts also, no? They have the body structure, a system to move the body structure, a sensory system, a power source to activate the muscles and sensors, and a brain system. In brain system, you are using AI. And if you notice, no, if on the left side, we have the robotics. This is actually the skeletal system. And on the right side, we have the metal structural system, no, of the robots. If you are going to put flesh, no, on this system or structures, we can maybe have President Duterte or you, no? But the difference actually is about putting what is outside. And if you notice, with Sophia, there was only a flesh, no, or actually a material being put into the robots, no, the metal structure of the robots. And we heard in movies, we have seen these movies, Wall-E, no, R2-D2, C-3PO, Bumblebee, Optimus Prime, and many other robots, no. Actually, these robots are intelligent, no. They can think, no, but it is first time if they can really think, no, because they will change everything, no. They will rule the universe, no. And I think that is something that Ateneo or the programs in the Ateneo will address also, no. It's really about ethical issues, no. But there are actually other robotics systems, no? And our interest is about this one, no? Agriculture, meaning how we can increase our production, no, by using robotic system. Then about biomedicine, no? Like the COVID now. So actually we can remotely, no, do operation, no, by using this technology. Then we have aerospace, and in food processing, maybe you don't have to wake up in the morning, then cook your food, no? Then maybe you can have your robot, no, to cook for everything for you. And the common one is really about machines, no, for industry, so car and other manufacturing. And for education also, no, playing like Lego Mindstorms and others, no. And I think maybe you heard about chatbot. Chatbot is, I think, the newest one, where in the future you don't actually have to go to school, no. You simply have to enroll, then somebody will send you the chatbot, then discuss everything to you, no, about technology, about your fields of expertise. But the Philippines top 10 imports, actually maybe you have been saying about this one, no? Number one is electrical machinery, no? It cost us about $27 billion to import, no? For about 24% of our imports. And this machinery, including computers, of $12.5 billion. So actually we can develop some of this equipment if we can only have engineers in the Philippines, maybe mechanical, electrical, or many other engineers that is focusing now on the development of these machineries. And for me, actually, I am pushing for this one, no, in the robotics engineering, that we have to develop our capacity and ability, no, to do something, no, especially in this era of AI and robotics. So what is the structure of the engineering program in the university? Actually, it is a ladderized or laddered program, no? Robotics is a 4-year program, but you can also pursue 3-year program, which is under, no, TISDA, and we can have certificates, no, 1 to 2. But maybe there are changes on this because now of the new, parang policy regarding the creation of TISDA, no? Or maybe we can give highlights on this one in the future, no? Where before you proceed to BS in engineering, you can first pursue diploma, no, so that you can work abroad or you can create your own technology. So these are some of the certificate programs. So maybe there are 16 at this point. So welding, drafting, machining, no, and many other technologies, no. And even one of these is enough for you to go abroad or to work abroad, no. And we are thinking really of providing you certificates, no. But at this point, we're still discussing with TISDA, no, because of COVID-19. It's hard, no, to discuss also with them in person, no. Then these are the competency. So we're expecting if you're a robotics engineer, you should know about machine shop works. And I think this is one of the challenges now with the first batch of the robotics engineering, because we can't go to the school to practice, but eventually we can cope up on this once everything becomes normal. Then you know about controllers, intelligence, audio and video, then robotics systems. So these are actually our partners. We have TISDA and we have AMSIN. AMSIN, or the Additive Manufacturing Center, has a lot of 3D printers where we can use the printers and we can ask our students to print their designs. Maybe you have to start with the mechanical drafting, then from there you are going to print it, then you can have the device. And also in 2019, we invited companies, small and medium enterprise from Japan. So there were about 10 companies who joined us, and we discussed about their needs. And this is actually the reason why we push for the offering of the robotics engineering program, because actually what they are looking are people who knows how to weld, to machine, to do 3D printing, and maybe to do robotics works. That's why we discussed and we told them we are still starting our program. So hopefully we can go back, then maybe we can send our students to have their OGT in Japan, or they can ask us to develop something for their organizations. And also we partnered with local companies. So we started discussing now with Mindanao Agricultural Machinery Industry Association, or MAMIA, in other agriculture-related organizations. So actually, they proposed to us to design our system. So they will fund us, because there's a lot of demand for agri. So we simply have to develop it. So maybe for mechanical engineering, electrical, robotics, and many other programs, we have really to locally develop these systems. But my plan also is really to set up the Ateneo de Davao University Institute of Robotics and Intelligent Systems, or we call it as IRIS or IRIS, to collaborate with other global IRIS. So there are also IRIS in other countries, Australia, Canada, Switzerland, and many other countries. So we can collaborate, then we can develop technologies. And I think it is really high time to do this, so that we should not be left behind. We have to cope up with what is really changing. We don't want to be actually underdeveloped. So what is the curriculum in BS Engineering? So basically, this is for first year. So you have about 28 units. Second year, you have maybe 27 units per semester. Then curriculum, third year, you have 27. But take note of the OGT, on the third year. This is actually a requirement for all programs. But in robotics, you can already do your OGT even during the summer of first year. And maybe you can work in Japan or in other countries, then it's good for you to do it once you already have the expertise on some scale type technology. Then in fourth year, so you have, by the way, this program is thesis based. You have to create your own technology. Maybe you can create Bumblebee, you can create a lot of challenging robots, then it's good for you. Maybe you can commercialize it. You can help people to increase their production. Basically, these are the courses, foundation. Of course, now important part here is really you have to have that mathematics foundation, and of course the foundation, you have welding, machining, and drafting. And for EI, you actually have about 7 courses for programming, and basically this programming. So I enrolled in Harvard, about university in EI, EI technology. Then actually I tried enrolling also in Stanford, just to help you, because I wanted to really share, to the students in robotics engineering to learn about these advanced technologies. And what is unique with robotics is you have now from it's a combination of electrical, electronics, mechanical, and computer engineering fields. That's why robotics is a cognate. So the cognate of robotics is basically these programs, and we tried combining them so that we can create something for the future. And that is actually what fourth industrial revolution is looking into. We have to develop robots that can do something with EI as their brains. Then, of course, these are some of the skills that you develop: CAD, CAM, programming, designing the machines, building and testing, then creating the prototype, then use of cutting-edge technologies like EI, machine learning, computer vision, and many other advanced technologies. Then you have to do research and development. Maybe you want to have a very small robot, then it's good. Then soft skills, meaning you have to have the problem-solving skill, teamwork, in communication, and lastly, and the most important one is about the ethical skills, no, in the design, because we do not want robots to be fighting with us in the future. No? And hopefully, if you graduate from us as robot engineers, robotics engineer, then maybe you can work in Russia, in US, in China, no? But if possible, we have to integrate that. We have to protect the people all the time, no, as robots engineers or robotics engineers. So these are CAM in CAD or computer aided drafting and machining. Then programming, if you really are happy doing programs, then designing, then building and testing, no? Then maybe you can have the cutting edge technology, artificial intelligence, computer vision, and many advanced technologies, no? So you have to learn about this in robotics engineering, and you have to do research and development, no? Depends on you. You wanted to do something like like Sophia or many advanced technologies, because I think this is really the future, no? Where you have to develop your own robot, no? Or maybe your equivalent robot. Maybe you can also do research about snake robot, rat robot, no, spider robot, and many other robots, because this can help, no, creating or producing or increasing our production and protecting the environment. And I think lastly, this is unique, no, because in the future, because of the 3D printers and maybe IoT will be integrated, and AI in robotics, we can create cyber organs. Then maybe if you know somebody has a problem with kidney, then you can create that kidney robot, no, to help your parents or your friends to survive, or you can create the lung robot. But this is in the future, no? And this will really happen. No? So eventually, we will be integrating this one, no, to this technology or to this program. So we have specialization, no? Agri, biomedical, automation, no? Aerospace, and many other technologies. No? Interesting technologies for the future. Then, as you see here, no, these are some of the specialization. So if you're a robotics engineer, we are hoping, no, that in the coming, after 4 years or 5 years, you can create your technology and you can help our farmers and yourselves even, no? Or you can actually commercialize technologies. And going back to the first industrial revolution, we started with a very simple technology, and take note, they are inventors and engineers. And if you want to pursue engineering program, no, then you can be one in the future. No? Maybe you can change the future. Maybe you can be like Tesla or Elon Musk, no, that can change the world, no, to help people really to become equal. No? I mean, to have that equality, no, between people. And I think that's all. And thank you for listening. Good morning to everyone. Okay na ko, kid? Okay na? Sorry, ah.
Thank you so much, Sir Randall. Sorry for the technical problems. Medyo nagkalisod lang ako sa the mute and unmute. So thank you so much for the talk, Dr. Randall Espina, on the Robotics Engineering and Industry 4.0. So for now, we will also entertain questions from the participants here in the Zoom webinar. So if you have questions or concerns or other maybe reactions to what Dr. Randall Espina has discussed about the Robotics Engineering and Industry 4.0, you may raise your hand or you may ask the question via chat. Anyone? So if there will be no questions for the participants, I will be the one asking questions. Okay. I will ask a question regarding the robotics engineering, and if ever person or a participant would get the correct answer, he or she would receive a prize. Okay, for the first question, what was the first technology that triggered the birth of the first industrial revolution? Again, what was the first technology that triggered the birth of the first industrial revolution? Okay, we have different answers here in the chat box. We have steam engine, steam powered machine, steam pump, air brake, steam power. Actually, the correct answer is steam engine or flying engine. So the person who got the correct answer and would receive a Gcash prize is Ernest von Claude Tolete. So congratulations, Ernest von Claude Tolete. We have the second question. The first humanoid robot that was granted citizenship by Saudi Arabia. What was the name of the first humanoid robot that was granted citizenship by Saudi Arabia? And this will also be the last question. The correct answer is Sophia. And the person who got the correct answer and would receive a Gcash prize is Zarina Babes Dandan. Congratulations. So again, kindly email Engineer Montani for the prize. I'm very, very sorry. It was Lance Tanedo. I'm sorry, Zarina. It's Lance Tanedo according to the technical team. So the winner of the second question is Lance Tanedo. Congratulations. So now we would like to award the certificate to Dr. Randall U. Espina for his power talk on robotics engineering and industry 4.0. So the certificate of appreciation is given to Dr. Randall U. Espina, the Dean of the ADDU Davao University School of Engineering and Architecture, Sense of ADDU Robotics Engineering, and for sharing his expertise to the learners of Ateneo de Davao, 6th of February 2021. Signed, Jude Aleph Solis, the President of Robotics Club. Signed, Ophel Amor Wiley, the Assistant Director for Academics, and Father Jessel Gerard M. Gonzalez, SJ, the Assistant Director for Formations. Thank you so much, Sir Handel, and congratulations, sir. At this point, we would like to request everyone to turn on their cameras and let's have a short picture taking with the speaker himself, Dr. Randall U. Espina. Okay, ready? 1, 2, 3, smile. One more. 1, 2, 3, smile. Okay, thank you so much, Dr. Randall U. Espina, for the talk. Thank you everyone for participating on the short picture taking. Now, I think this would be the most awaited part of the learners, right? To know more about the different courses offered by the School of Engineering and Architecture. So we have the 10 courses, namely the Aerospace Engineering, the Architecture, the Chemical Engineering, Civil Engineering, Computer Engineering, Electrical Engineering, Electronics Engineering, Industrial Engineering, Mechanical, and Robotics Engineering. So for now, we would start by having the aerospace engineering. So the department chair of the aerospace engineering is Dr. Rogel Mari Sese, the chair of the Department of Aerospace Engineering. So, Dr. Sese, take it away.
Hi, morning everyone. Thank you, Kid. To Dean Randall Espina, our Dean at the School of Engineering and Architecture, to Assistant Dean Renil Barroca, to my fellow co-chairs in the SEA family, and also, of course, to the teachers and students of ADDU Senior High School. So it's my pleasure to talk to you today, to share to you about the aerospace engineering program, which is one of the exciting programs of the Ateneo de Davao University. So can I just share my screen? So if possible. Okay. Great. Go. So aerospace engineering is one of the youngest programs of the SEA. So by the way, can you see my screen?
Yes, sir, we can see your screen, sir.
Okay, thank you. Okay, so aerospace engineering is one of the youngest programs of the SEA family. So we started only on in 2018. So we are now on the third batch. We just had the third batch of aerospace engineering students here at the university. So currently I'm the chair of the aerospace engineering department. So by profession or by training, I'm an astrophysicist. I'm one of the 3 astrophysicists in the Philippines. So I'm very happy that Ateneo is actually pushing with the aerospace engineering program. Just to give you an idea on, probably you've heard of the program in one form or another, but to give you or to enlighten you on what the aerospace engineering program is, when you talk about aerospace engineering, this mainly focuses or talks about or discusses the design, development, manufacturing, testing, operation, and maintenance of aircrafts, spacecrafts, and other related systems. So in aerospace engineering, this is actually a combination of 2 different engineering fields. The first is the aeronautical engineering, which is more concerned with aviation and aircrafts. And the other is the astronautical engineering. So when you talk about astronautical engineering, this is the part wherein you look into space systems, satellites, rockets, even deep space probes like the recent Mars rover that landed. And this makes the field itself a very exciting area wherein you can really push the forefront and the boundaries of innovation and technology. So aerospace engineering and space technology and aerospace technology in that sense is always in the forefront of innovation and cutting edge technology, because this allows the program, or this allows the field to really create new innovations and make it due to the varying requirements in aviation and in space technology. So here in Ateneo de Davao University, we have this program combined into one, the aeronautical part and the astronautical part combined into one single program, which makes it really challenging, at the same time very exciting, because you can really put in your imagination and do and create things that you at first you would only think or you would only imagine, but eventually you can make them into a reality. So Ateneo de Davao University is currently the only university throughout the whole country that offers the true aerospace engineering program, because we focus not just on the aviation side but also on the space side, which makes it a true aerospace engineering program. So this makes us a leading university in the whole country when it comes to aerospace engineering. So currently, when you talk about aerospace engineering, we have specialization tracks. So in the 4-year program, so you of course you are going to be trained in calculus, in mathematics, in physics, in even in instrumentation technology, in mechanical engineering, materials engineering, and even in a little bit also on robotics engineering. So this also a convergence of the different fields that makes it really a confluence and a really a strong program. So currently we have 3 specialization tracks in here in the university. So this is the aerospace propulsion. So when you say aerospace propulsion, this is just this is related to how do you propel or how do you move aircrafts, so mainly through the use of engines, and also how do you move objects into space, which is primarily done through the use of rockets. So basically, this is what you call your rocket science. So when you talk about rocket science, this is aerospace propulsion. In addition to this, we also have the aerostructures and materials. So so of course, when you are bringing objects into space or flying in high altitudes, the materials needs to very strong and very has to withstand the harsh environment of high altitude and outer space. And this makes it also a challenging endeavor. So creating new air composite materials for aerospace engineering is also a cutting edge field. We also have the track in astronomy and astrophysics because part of the work of an aerospace engineer, especially when you work in satellite technology, is you track the different objects that are orbiting around the Earth. So in order to make it, to prevent issues such as collisions of satellites or collisions of rockets and so on. So you can do this by doing astronomical observations. You have radars and telescopes that can actually detect these objects, and by knowing how these different objects would behave in orbit, you can actually predict when these objects will eventually to orbit, or if these objects or these satellites will collide with each other. So you can prevent issues like that. In the future, we are also looking at offering additional tracks, particularly in unmanned aerial systems. So when you say unmanned aerial systems, these are drones. These are aircrafts that doesn't have or doesn't need a human being to be on board. Of course, satellite technology is one area wherein we are really looking forward into developing small satellites, microsatellites, nanosatellites. So now the technology is very advanced to the point that you can create satellites that you can fit in the palm of your hand, or what we call CubeSat. So it's no longer limited to the huge satellites. Now it's possible that even a university or a university student or a group of university students can make their own satellites. In addition to this, we also look at our upper atmosphere research. So understanding the space environment, what are the different hazards and how we can mitigate those hazards is very important, especially when you talk about space exploration. So analysis and studying not just the atmosphere, but also the effect of the sun on the atmosphere makes it a very important field. And lastly, on space communication. So how do you connect, or how do you use satellites to communicate in different points or connect different points of the Earth, and make sure that everyone is connected or linked together. So these are just some of the specialization tracks that as future aerospace engineers or future aerospace engineering students you will be embarking on. So it makes it, if you can see, this is actually a cutting edge area wherein you can really imagine and dream of things that and eventually make those things or instruments come true. So as a career, for what are as future graduates of aerospace engineering, what are your possible career opportunities? Of course, as aerospace engineer, you're trained to work in aviation and also in astronautics. So that makes you a very dynamic and a very prolific person. You can adjust to whether it's in atmosphere or in space. Spacecraft and aircraft designers, these are the usual jobs of an aerospace engineer. Rocket scientist or a missile scientist. So rockets and missiles are essentially the same thing. It's just a matter of what are the different payloads it's being carried. as dynamicist, you can actually this is where you track different objects orbiting the Earth. How do you calculate, or how do you move satellites in space from one point to the other, from one orbit to another, and making sure that the movement or the transfer of orbit is done efficiently with minimal risk. So that's a job of an astrodynamicist. Aerospace materials engineer. So this, as I mentioned earlier, you have actually a different. You can create new materials that are more resistant or can withstand the hazardous environments of space. Aerospace researchers or scientists, unmanned aircraft systems engineer, or a drone scientist or drone engineer. So using unmanned aircrafts, you can actually use it for various functions like remote sensing, Earth observation, and even for disaster management or disaster relief. As aerospace engineers, you can also work as mission payload specialists, creating new instruments that can go into space missions, that can go and be tested on board the International Space Station. You can also become an astronomer and astrophysicist. So this is related to the job of an astrodynamicist. You can start observation. So if you have a very strong interest in stars, observing the sky, this is actually the job of an astronomer and astrophysicist. Missions operations engineer. So if you're more comfortable with supporting missions, so when you have missions in space and even in aircrafts, you don't actually, it's not just one person working on it, but also a host of other persons working. And also as a space lawyer, this is an exciting field because there's also the legal aspect of aerospace. So that makes it also a dynamic field. So here in the country, we have different opportunities for employment with aerospace industries. We have an Aerospace Industry Association in the Philippines. We have the newly created Philippine Space Agency, which I was part of the team that actually created the Philippine Space Agency. You can work with the Air Force as well, and also with the Society of Aerospace Engineers. But even in the private sector, such as Airbus Defense and Space, Lufthansa Technique, and eventually, if some of you in the future might be willing for other companies like SpaceX and United Launch Alliance. So, and for what we say, what we say in aerospace engineering, because of the nature of the field itself, in aerospace engineering, the sky is not the limit. So for other people, we would say that the sky is the limit, but for aerospace engineers, the sky is not the limit because we go beyond the sky and upwards into space. So to end my talk, I'll just show you one of the future plans for aerospace space development here in the Philippines. So this is actually one of the long-term plans is to develop a rocket launch facility, which is actually situated here in Davao region. Actually, I'm currently in Mati Airport, which is very close to the potential launch site. And if you notice this image on the right, that's actually taken only this morning when we flew an airplane over the potential site on where this launch facility will be created. So that's my shoes there. So we flew an ultralight aircraft to survey and to do an ocular inspection of the site. So this is actually not just the future, not just for Ateneo de Davao University, but also for the whole Philippines as well, because this can bring in a lot of technology, a lot of innovation and also help a lot of the other industries in manufacturing and other engineering programs. So that's why I'm here currently in Mati in Davao Oriental to see how we can really start working now. And by the time that you become students of aerospace engineering, you might have the opportunity now to launch your own rockets as a test flights from this facility that will be constructed in the next few years. So with that, I guess I hope that my short talk on the aerospace engineering program would entice you to enroll and be part of something that's really cutting edge, breaking the barriers and pushing the forefront of technology here in the country. Thank you. So if there are any questions, I'll be happy to answer any questions if there are.
Thank you so much, Dr. Cesar, for the presentation of aerospace engineering. Next course would be architecture. So we have architect Wilfredo Policarpio, the chair of the architecture department, to present and discuss a brief background on architecture. Take it away, sir.
Good morning to Dr. Randall Espina, our Dean, to Dr. Renil Varoca, our Assistant Dean for the School of Engineering Architecture, and for the rest of the department chairs, and to the senior students of the Ateneo de Davao University. I would be glad to introduce briefly the architecture program in the university. Okay, can you show my screen?
Yes, sir.
Okay, so this is the nature of the field of study in the architecture program. We are into planning, because the planning and designing is a different field. So we are into planning and architectural designing. And also we are into structural conceptualization, but the architects will not design the structural integrity of the building, but we do the conceptualization, because the structural design would be at the field of the civil engineering. Okay, we also design, build structures, and including the environment. We do look into the environment when we design buildings and structures. And also we do specifying. This specifying includes what materials to be used, what the kind of equipments to be used, what kind of materials to be used in the buildings. And also in the architecture, we do supervising and giving administration and responsible direction into the building and into the renovation, alterations of buildings, and also the building environments, not just the buildings, but also the environment surrounding the structure. And also in the architecture program, we do architectural design in engineering structures or any part thereof. We do the static, the static of the buildings, because the civil, the engineering program do the skeletal, the integrity, but in the architecture we do the statics, scientific, and also the coordination of all spaces in the structure, which enter into the production of the complete building or structure. Okay, we do perform medium and advanced preliminary studies, because we see to it that the design of the structures will be on the owner's instructions, and also we do as the what they call this, as advisor of the client. We interpret their briefings to the architects. Okay. We also do consultations, and then also again the specifications, and then conferences, evaluations, investigations, and do contract documents and oral advice and directions to the client. Okay. Regardless of whether the persons engaged in such practice are the residents of the Philippines, or have this principal office or place in the business in the country or another territory. And also, regardless whether such person are performing one or all of these duties, or whether such duties are performed in person or as directing head of an office or organization performing them. Okay, so this is the overview of the architecture program, and the following are the specific professions wherein the graduates of the architecture program may go after the required qualifications. So we have two specific careers, one for the graduates and one for the professional. Okay. So for the professionals, we can go into what we call architectural design, pre-design services for architecture, which is the main job of the architect. Okay, we do the design of the structure, we do the design of the houses, the buildings, and then we do the planning. We do the what we call this the space planning, wherein we arrange all these areas that can provide a good work of architecture. Okay, and then we do housing. Uh, we can do physical planning. Wherein physical planning, we have the what we call the outside of the you know the structure, which is the different location of each buildings in an area. We also call this as town planning and city planning. Okay. Then the letter D, it's the urban design. It deals with the spaces in between buildings. What the In short, it is the spaces such as parks, playground, and gardens and landscaping in between buildings. This is the design uh, of an area wherein you go into one building to the other, and then that area in between them you will that is what we call the urban uh, planning, urban design. And then for also for the professional, we do community architecture where we design such as what we call the planned unit development, wherein it is a mixed community, a mixed use area, wherein there is a convergence of people. Okay. And then we also do facility planning. What we do, facility planning is all about schools, factories, etc., and then other facilities that do factories. Okay, and then we have construction technology, wherein we also the architect can invent or can introduce new body of knowledge in the construction industry. Okay, and then we do construction management and project construction management and project management is almost the same, but the project management is the architect will be at the project right at the start of the inception of the project. Okay, and then the construction management is wherein it is on the construction itself. Okay, you will manage the construction of the project. And for building administration and maintenance, this is it deals with how you will maintain the integrity of the building, such as the malls, such as the condominiums, because we have to maintain and maintain the integrity of the building, so it will last for long. Okay, and then for real estate development, it deals with the development of a real estate for construction or for the development of an area, subdivisions, and all of the areas that deals with the real estate. And also, a professional architect, a licensed architect can go into architectural education, such as what we are doing in Ateneo. Okay. For research and development, this is the same as the letter G, the construction technology. We do research for viability of any introduction for development of in the construction industry or such materials or anything. For restoration and conservation is also a forte of the architect. Okay, such as restoration of the old buildings and then conservations of all structures. Okay. Because restoration and conservation is a different field. Because in restoration you will retain the physical aspects of the structure. Okay, for our architectural interiors, this is because we cannot say that we do interior design, because there is another group for professionals that are dealing with our interior design, which is the interior design group. So we do architectural interiors, wherein it is the finishing of what are the finishing of an interior. But we do not arrange any interior such as furniture, but we can we can advise. Okay, but that is it is also it is now the field of the architect interior designers. So for the architects, we do architectural interiors instead. Okay, and then we also can provide expert witness service, such as for the litigation processes, wherein they would like to get the advice of an architect. Okay, and also we do design build services, wherein we design because the architect is in good position to implement what he designs. Okay, so it means that we design the projects, we design the buildings, we design the house, and then we will build the house for the client. But in design build services, we do not act as the contractor of the building, but we do this the build the structure by means of administration and supervision only. Okay, and that is not limited. The following careers are not. We do have other areas of or careers that we can go into after we get our license. Okay, not only limited to the following. Okay, and for the graduates, until you get your license, you can work as an architect in architectural drafting. Okay, as computer aided drafting and design operator. Okay, because somehow architectural drafting is still present in the and in the industry. Okay, we cannot do away with the manual drafting. Okay, and then also you can go into project coordinator, such as you will be assigned in the project, and then you will be the assistant, or you will be the manpower of a project management team. Okay. You can also go into while you are not yet licensed. You go into as a project supervisor or inspector. Okay, you can also render your services as a project estimator. Okay, and then for rendering, you can have it on manual and electronic, such as we use the SketchUp or the what do you call this the Lumion software. Okay, and also there is also a big business in scale modeling, because some of the projects that will be such as the developer, they do require scale modeling. Scale modeling is the scale model of the structure that will be built. Okay. So this is the architecture program in the university. We have produced also as of now, until now we wala pang board exam, but we have produced also we have also produced two top-notcher, number one in the board exam, and also architecture is also in program in the university. They also landed in top 10 in the board exams. Okay, I think that's all for the architecture program, and thank you for listening.
Thank you so much, Architect Policarpi, for that. Before we proceed to the next department, I would like to apologize because I would like to remind the department chairs that we will be having a short period of discussion only, in the interest of finishing the webinar and the career orientation on time, because both the technical committee and the organizing team of both the School of Engineering and Architecture and the senior high school would like to respect the lunch break of everyone. Okay, so to proceed, we now have Engineer Maria Lea Flor A. De Castro, the Chemical Engineering Department Chair of the School of Engineering Architecture. Take it away, Ma'am Lea.
Thank you, Sir Kid. Good morning, everyone. I'm pleased to share about the Chemical Engineering program. The chemical engineering is a profession that involves the conceptualization, development, design, improvement, and application of safe, healthy, ethical, and economic ways of utilizing materials and energy in unit processes and operations for the benefit of society and environment through the knowledge of mathematics, chemistry, biology, information technology, and other natural, applied, and social sciences gained by study, research, and practice. This definition from CHED already tells us what we as chemical engineers do. Can we go back to the previous slide, please? What we chemical engineers do, how we do it, what we use, where we use them, why we do it, what we should learn, and how we can learn. Next slide, please. So you would see in this slide some of the fields under our scope of practice and fields of specialization. And also in this slide, you would see the images showing the different activities aside from the class lectures and discussions that we usually do in the chemical engineering department to facilitate the holistic learning of our students. So we encourage our students to engage in the community through service learning. The top left image shows one of our students explaining paper and soap making to students from Magtuod National High School, while the bottom left image shows our CHA booth where our students showcase their projects and research outputs. We also expose our students to the different industries where they may specialize and allow them to have a peak of professional chemical engineering practice. So you will certainly find chemical engineers in industrial plants that produce soft drinks, paper and boxes, paints, sugar, beer, cement, animal feeds, fuels, energy, and more. Or in facilities involved in the management of water supply, wastewater treatment, and solid waste management. Or in research institutions with projects involving materials, environmental, or energy engineering. The bottom right photo shows last year students happily posing after presenting the research outputs to our science and engineering community. Next slide, please. So to close, I am proud to share that the Ateneo de Davao University was recognized by the Professional Regulation Commission as a top 2 performing school in the Philippines under Category B for the outstanding performance of our graduates in the last Chemical Engineering Board exam. So the Chemical Engineering program may not be a walk in the park as it certainly carries a certain degree of difficulty, but if this is the career path you are most interested to take, our chemical engineering faculty members are committed to ensure that you gain the necessary knowledge, skills, and character of a competent and responsible chemical engineer. So thank you for your attention.
Thank you so much, Engineer Maria Lea Flor de Castro, for the presentation on the chemical engineering course. Next, we have the Civil Engineering Department, headed by Engineer Ken P. Cusaras. Take it away, Sir Ken.
Hello. Madunggan ko, kid?
Yes, Sir Ken.
Okay. Greetings to everyone. Okay. Okay, so what is civil engineering? If I were to borrow the definition from the Institution of Civil Engineers, civil engineering is a discipline of engineering which involves the construction and design of physical and natural built environment, which also include public infrastructure such as roads, bridges, dams, airports, sewer systems, canals, pipelines, buildings, and railways. Civil engineers are the frontliners of the Philippines' golden age of infrastructure, which is popularly known as the current administration's Build, Build, Build program. So I hope familiar kayong lahat nito, no? But this is for a large-scale view. In smaller scale, civil engineering touches us throughout our day. Think of a civil engineer when you just simply turn on your faucet to take a shower, wash dishes, drink clean water, dispose wastewater, build your family's dream house, commercial buildings to withstand a strong earthquake, or even develop a huge and sustainable farm lots. Or even just by driving or commuting to work on roads, bridges, highways, interchanges, through synchronized traffic lights, have a road trip to Bukidnon to Davao Highway in a wide curved roads, or even take a walk or bike in the recently opened Davao Coastal Road. We also provide structures to support agricultural development through irrigation, canals, and other improvement in water resources. So how to become a civil engineer? So for you to become a civil engineer, you must be able to complete a degree in BS in civil engineering. In Ateneo, this is a 4-year course. And of course, I highly suggest that you enroll a degree in a highly reputable university such as in Ateneo de Davao. The CE department of Ateneo de Davao is currently the largest department of the School of Engineering and Architecture. It is one of the best performing civil engineering schools in terms of board exam passing rates. In the last 5 years, the passing rate is always above the national passing rate, implying that our graduates really have the high chance of passing the board exam to become an eligible licensed professional. Due to this exemplary performance, the university has been tagged as one of the best civil engineering schools in the Philippines, and if not the best in Mindanao. So these are some of the employment opportunities of civil engineer. Next slide, please. And these are the 6 major fields of civil engineering. So for water resources, we analyze, design, and build water supply system, irrigation, and wastewater disposal. For construction project management, we organize and manage a construction project and work with an architect so that we can finish it on time. For structural engineering, we design structures that yield safe, stable, and secure framework that can withstand strong earthquakes. And then for transportation engineering, we plan and design highways, railways, airports, seaports, and other methods of transportation. For geotechnical engineering, we study the natural form of Earth's soil structure where your project is to be erected. And then lastly, we also cover environmental engineering together with the chemical engineering profession to contribute to environmental improvement and mitigate adverse environmental effects such as pollution. So civil engineering jobs are always in demand, especially in developing countries such as in the Philippines and most especially in Davao City. So in Davao City, we have a lot of large projects. That includes the construction of the first ever uh, Davao Samal Bridge, the implementation of the Mindanao Railway Project, the bypass roads from Barangay Turil to Panabo City, and of course, the booming urban development that contributes to the skylines of Davao City, including the kabilaang mga condominium projects, schools, mixed-use development, such as Davao Park District by MegaWorld, the Davao Global Township by Cebulan Masters Incorporated, the Azuela Cove by Ayala Land, and then marami pa, many to mention. So if you want to be part of the team of builders and large developers, then you might consider enrolling in civil engineering. And please do note that according to Finance Secretary Carlos Dominguez, Mindanao will always stay at the front and center of the Build, Build, Build program. So I think yun lang siguro.
Thank you so much, Engineer Cosares, for the presentation on the civil engineering course. Now, we'll have Engineer Dexilito Badillas, the Department Chair of the Computer Engineering. Sir Dexy.
Hello, good morning, everyone. I'm Sir Dex from the Computer Engineering Department. Next slide, please. Computer engineering is basically a combination of 2 courses, electronics engineering and computer science. And there's also a mix of electrical engineering. And then next slide, please. There are basically 4 main paths that you want to choose if you want to be a computer engineer. So you can be a software architect, database administrator, hardware engineer, and network architect. You can see a large gap between those 2 because on the left side, you can be a software designer, computer engineer, or you can be a hardware designer, computer engineer. You can actually integrate both, which is usually the case. So if you want to tinker with electronics, computer engineering is your way to go. So I think we don't have much time, but I suggest that if you have a Discord, you can join us in our Discord server and we can like help you or discuss with you anything about engineering as a whole. So I think there's a link below. You can join us using that link. So hopefully, if you have more questions, you can ask us from here. Our upperclassmen is also there. Which can help you choose your engineering course. So thank you and good morning once again.
Thank you so much, Engineer Badillas, for the presentation on computer engineering. Next, we would have the chair of the Electrical Engineering Department. We have Engineer Fortunata Pompeya Nicolas.
Hoy, saan nyo kinuha yung... Ay, sorry.
Yes, Ma'am Pom.
Ayan. Okay, good morning to everyone. Let me share my screen. Sorry, I cannot share my screen.
Now we will handle the slides, ma'am.
I have my own, sorry ha, I added one slide. Kasi na...
Okay. Technical team, please. Sir Mike, mag-share screen daw si Ma'am Pom.
Sorry. I'll do this in 2 minutes. Okay, di pa rin. So, okay na. So, good morning. So, electrical engineering is a profession that involves the conceptualization, development, design, and application of safe, healthy, ethical, and economical and sustainable generation, transmission, distribution, and utilization of electrical energy for the benefit of society and the environment through the knowledge of mathematics, physical sciences, information technology, and other allied sciences gained by study, research, and practice. So in Ateneo, so the batch 2020 has not yet been able to take the board exam due to the pandemic. But from 2015 to 2019, the passing rate of our graduates has consistently been 100%. As for the scope of work, so most of our work is confined in this electrical power system. So you have the generation, transmission, subtransmission, which includes the Double Light Power Corporation, and of course, including the secondary customers, commercial, industrial, and residential users. So including the design of their electrical system. So the scope of work, according to the RA 7920, is a consultation, investigation, valuation, and management of services requiring electrical engineering knowledge. So design and preparation of plans, specification estimates for electrical power systems, power plants, power distribution systems, and supervision of erection, installation, testing, and commission of power plants, substations, transmission lines, industrial plants, and others. Then supervision of operation and maintenance of electrical equipment in power plants, industrial plants, and so on. We can also supervise in the manufacture and repair of electrical equipment, including switchboards, transformers, generators, motors, apparatus, and others. And teaching of electrical engineering professional courses, and you can go to sales, and distribution of electrical equipment and systems requiring engineering calculations or applications of engineering data. The fields of specialization may include but not limited to the following: power system operation and protection, power plant operation and maintenance, advanced electrical system designs and inspection, sales and entrepreneurship, engineering education and research, instrumentation and control systems, construction and project management, software development, electricity market, and safety engineering. Thank you, that's all.
Thank you so much, Engineer Fortunata Pompeo Nicolas, for the presentation of the Electrical Engineering Department. Next, we would have the Department Chair of the Electronics Engineering. We have Engineer Joseph Rene Villanueva. Sir Opep.
Hello, good morning, everyone. To the administrators and the students, most especially to the students, I'll try to present a little about the ECE program in less than 2 minutes. Okay, next, please. Just to give you a broad background, electronics engineering actually stemmed from electrical engineering, but we have now our new law, which is the RA 9292, which basically changes the name from electronics and communications engineering to only electronics engineering. And in the same law, next slide, please. These are the scope of works of an electronics engineer. So we have telecommunications, broadcasting, ICT, computers, etc. So if you see, we are a very interdisciplinary and intradisciplinary profession. It's very close to computer engineering, electrical engineering, and even your robotics engineering. So next slide, please. We have these career paths and opportunities. So one of the trending careers now is in telecommunications with the advent of work from home, study at home. We are at the forefront of providing reliable communication systems to all clients. And then we also have industrial automation and control, broadcasting and CATV with the advent of digital TV. And not so common is in construction. So we are in charge of FDAS, fire detection and alarm system design, structured cabling, telephone systems, etc. And then we also have smart systems design in the Internet of Things. And then you can also go into R&D or research and development. The common researches from the faculty now are in renewable energy, in communications, in Internet of Things, etc. And then you can also go into business and commercialization. So last slide, please. Next, please. So if you want to know more about ECE, I'll be glad to answer your questions in another forum. And you can also go to our student org page in Facebook. Just search for Telecoms. And let me close with this. With these words, so let's help bring the world closer through telecommunications, make life easier through smart systems integration in the service of the people at the forefront of the next industrial revolution from and for Mindanao and the world. So come and please join the ADDU ECE family. Thank you.
Thank you so much, Sir Ope, for the presentation on the electronics engineering. Next would be a presentation on industrial engineering. The department chair will be yours truly, Engineer Francis Christopher Bation. So share screen, please, Sir Mike. Your screen, rather. So if you have questions later, you can email me at fccbation@ado.edu.ph. So what is industrial engineering? So it is an engineering profession that figures out how to make things better than its current design. So that's the goal of an industrial engineering, is to make all things better. It aims to maximize resources, minimize cost, eliminate waste, and increase productivity. IEs develop and innovate integrated systems of men, money, materials, and information. Next slide, please. So an industrial engineer mainly focuses on logistics, the systems optimization, the efficiency and effectivity, and the engineering management. So we bridge the concept of the business and the engineering perspective. For the job opportunities, we have the quality and industrial engineer. The operations analyst could be assigned in manufacturing and different warehouses. Ergonomist, so the goal of an ergonomist is to make sure that a human being is safe in different kinds of work. Next is a logistician or a supply chain manager, making sure that all items, the finished goods, are delivered on time to the different communities and the end users and consumers. We also have the project and risk advisor, customer service engineer and manager, and many, many more. So next slide, please. So we also have testimonies from alumni of the ADDU IE. So according to Engineer Lawrence Ignatius Marañon, the edge of an IE Atenean graduate in the workplace is the culture of magis and the constant mindset to do more, because doing more would entail to improving a lot of things. And last slide, please. According to Engineer Anthony Paul Pasha, an IT delivery and retail services manager of the Robinson Supermarket, perhaps the most important learning that I got from the program is how to be people and process oriented to address different challenges, deliver results, and achieve goals. So if you have more questions regarding the course, regarding industrial engineering, you may ask here in the chat box or email me at fccbation@adu.edu.ph. So that's it for the industrial engineering department. For the next department, we have Engineer Marion Albert Mozo, the chair of the Mechanical Engineering Department. Sir Albert. Please do unmute Sir Albert Mozo.
Hello, good morning. So, I'm Engineer Marian Albert C. Mozo, Chair of the Mechanical Engineering Department. So, the Mechanical Engineering program in Ateneo is one of the pioneering or the oldest program offered by the School of Engineering and Architecture. So, to give you the brief course path for the ADDU Mechanical Engineering graduates, after you will finish this curriculum of the Mechanical Engineering of Ateneo, you will be able to do like consultation, evaluation, investigation, and management services required for mechanical engineering knowledge. Second is you will be able to do engineering designs, preparation of plans, specifications, and project studies or estimates for mechanical equipments, machineries, or processes of any mechanical works, projects, or plans. Third is you will be able to do the management or supervision of the erection, installation, alteration, testing, and commissioning of mechanical equipments, machineries, processes, and mechanical works, projects, or plans. Then fourth, you'll be able to do the supervision for the manufacturing, sale, supply, distribution of mechanical equipments, parts, or components. Next. So the mechanical engineering or from the Ateneo de Davao University ranked first in the August 2019 licensure exam for mechanical engineering for category 10 to 49 examinees. So not only the mechanical engineering excel in the extracurricular but also in the academic sides. That from the PRC we are able to do the performance of 100% among all the participating schools, colleges, and universities. So the program constantly producing holistic mechanical engineering engineer graduates. Also, one of the extracurricular activities of the ME students is we were able to participate in the Shell Eco Marathon. So the Shell Eco Marathon is the worldwide energy efficiency competition sponsored by Shell. So the participants build automotive vehicles to achieve the highest possible fuel efficiency. So the mechanical engineering students are able to participate together with the other programs in School of Engineering and Architecture. So the students able to design a fuel-efficient car prototype moved by the internal combustion engine participated in the Shell Eco Marathon. Next. I think that's all for mechanical engineering. So if you have questions, you can contact me. And you can also contact the Secretary of the School of Engineering and Architecture. Thank you.
Thank you so much, Engineer Albert Mozo, for the presentation on the mechanical engineering. So earlier, we also had the discussion on the robotics engineering during the talk of our Dean, Randall Espina. So for now, we'll be having the presentation on the scholarships and the admissions on how to apply at Ateneo de Davao University, the School of Engineering Architecture, and the different offerings for the scholarships. So we have Engineer April Salazar, the head of the scholarships and the admissions for the School of Engineering Architecture.
Hello, good morning. Sir Mike, ano ko sa slide, Sir Mike. So good morning, I'm April Salazar. I am an electronics and communications engineer, and I am currently the scholarship and admissions and scholarships in charge for the School of Engineering and Architecture. So if you have questions regarding scholarships and other related to admissions, you can refer them to me. Okay, next slide. For the enrollment process, so for everyone's information, our enrollment will be open from April 1, 2021. So with our process is through online. So you just go to www.addu.edu.ph and then you click the enlistment link for the undergraduate applicants. So you input there your data and then fill out the required admission data in the enlistment link. Then once completed, you will be receiving an email as confirmation to that information that we received, that the admissions have received your information. Next slide, please. Step 3, once payment, you'll have to pay. No, so once payment is done, you go to enlist.addu.edu.ph and upload your proof of payment. So since you're from Ateneo de Davao University already in our senior high school department, you don't have to forward your you don't have to submit physically your credentials. It will automatically be transferred to the college registrar. So step 4, that's once uploading of proof of payment, you just have to wait for you to receive your confirmation. So you'll be given an account, and that account will be used, you'll be given a student account. That account will be used to access our sis.addu.edu.ph. So in that system, you'll be able to see your subjects, your teachers. You'll be given an Ateneo email where your teachers will also communicate with you through that channel. Okay. Next is for the scholarships. So I have here listed, courtesy of the Admissions and Aid Office, the frequently asked questions for scholarships. So number 1, what are the scholarship programs offered by the school? So we have 2. We have JSF, that's exclusive for valedictorians and salutatorians. So I hope yung ating mga Valle at Sali dyan ay dito mag-enroll. So that's 1. We have JSF, and we have the grant in aid. How much are the grants given to the students? So for JSF, 100% for valedictorian, 50% for salutatorian. The grant in aid ranges from 10% to 100%. So it will depend on the availability of slots and of the budget. Next slide, please. So how are you going to apply for the scholarship program? So application will still be online. So please be updated with the Facebook page of the College Admission and Aid from the in FB. I'm sure everybody has FB. Please also be updated on the announcements from the FB page of the School of Engineering and Architecture So that's also one of the channels where you'll know the latest updates on the scholarships. Also, when is the application deadline? Okay, so for this first semester, please bear in mind that the application will be open first week of April, so the same as during the enrollment period as well. And the deadline will be last Friday of April. So it's very important to note that you have to process your application during the months of April. Next slide, please. What are the requirements? So basic requirements are as follows. You have the ITR or income tax return of your parents if they are working, or if you have a certificate of low or no income from the barangay and it has to be stamped from the BIR. Then you have the senior high school report card with at least 85% and above as your average. And of course, your filled out online application form. Next slide, please. So what happens if you have a government grant? Is it okay to apply for a GIA or JSF grant? So for DOST and CHED grants, if you have those, it is allowed. However, GIA or JSF grant will be adjusted if the total scholarship grant of the scholar exceeds the student's total assessment. So STEP or EBSU, these are from the CHED scholarship or the government scholarship also. They do not allow having GIA grant, but they will allow students with JSF. So does GIA or JSF have allowances? Both grants do not have allowances. Okay, next slide, please. How do we know that you'll be accepted? So we will text or email the applicants. So make sure that your mobile and email address are active. So we will be, for the School of Engineering and Architecture, we will be conducting an interview. So make sure that your number is accessible so that we can really contact you or text and call you para pag mag-call nami for an interview, you'll be available. So I am an ADDU Senior High School and have GIA. Will I also apply? Yes, it's not automatic. You still have to apply for a GIA for the college. So given the katong requirements as I've mentioned, so you just follow the requirements. It's not automatic. Next slide, please. So how are the grantees chosen? So the committee, so for the each department or each school has its own committee. So the committee will deliberate on the information that you've provided as well as the document. So we check it also based on the need, based on the qualifications. So is there a grade that scholars need to maintain? Yes. QPI of 2.5 for GIA and a QPI of 3 for the JSF scholars. So these are the average requirements also. And I think next, yes. So once again, I'm April Salazar. I'm your scholarship coordinator. You may email me at amsalazar@fado.edu.ph. Thank you very much.
Thank you so much, Engineer April Salazar, for the presentation on the admissions and the scholarship. For now, we'll be having a 5 to 10 minute open forum or question and answers for those students and learners and even other participants who have questions with regards to the different courses offered by the School of Engineering and Architecture. So you may raise your hand or you may ask your questions via chat. Here's a question for the aerospace engineering, Doc Sese. What's the difference between aircraft and aerospace engineering?
Is Dr. Sese around? Earlier, he informed that he's on transit from Mati.
Oh, okay. So maybe the question will be answered via email na lang. Okay. A question for Engineer Ken Cosares for the civil engineering. What will you do to become a structural engineer? What would be the steps to become a structural engineer?
Hello.
Yes, sir, Ken.
To become actually ang structural engineering is just a field of specialization sa civil engineering. Any licensed civil engineer can proceed to structural engineering. by say studying graduate studies in UP kasi sila yung nag-offer ng Master of Civil Engineering major in Structural Engineering. But before ka maging structural engineer, ang qualifying criteria is that dapat meron kang experience sa construction industry, designing buildings. Kahit wala kang master's degree in structural engineering, you can become a structural engineer. But nowadays, kailangan mo lang talaga mag-proceed to postgraduate studies.
Okay, thank you so much for that answer, Engineer Cosares. A question for Dr. Randall Espina for the robotics engineering. With the success of the Perseverance rover landing on Mars just recently, how will this scientific breakthrough open a window of opportunity for the field of robotics engineering and for the Filipino youth? Again, sir, with the success of the Perseverance rover landing on Mars, just recently, the field of robotics engineering and for the Filipino youth who are interested to pursue in this field.
Yeah, actually, that's why in robotics engineering we have that specialization in aerospace robotics. So actually, we are really trying to collaborate also with the aerospace department so that our youth, or our future students have the experience or expertise in in space robotics. But of course, there's a lot of applications for robotics, and if you notice now, we are really shifting into robotics. But the robotics that I am talking here is with the integration already of the artificial intelligence. Robotics in the 50s to even to 1990s was a different robot. This robot actually just programmed to work as designed. But the robotics now, it is actually trying to learn. Meaning it is, if you have to put information, then you have the algorithm, and that robot will learn. I think that is also the algorithm being embedded into the perseverance robots in Mars. So meaning that robot can actually learn what it is doing. Meaning with the environment, so with of course the information gathered by this robot, so it is actually learning. So that by doing it, then in the future it can really survive in Mars, like human beings. I think that is really the future of robotics.
Thank you so much for your answer, Sir Randall. Another question for you, sir. As the Dean of the School of Engineering and Architecture, what will be the setup of learning for the engineering courses and classes for the next school year? And how can the school assure the quality of education even if it will still be online classes, sir? This is a question from a student learner.
Actually, it is really a challenge for us. In our case, we are also learning about this online learning. And actually, I think even in the first semester next school year, we still are going to have that online classes. Maybe after all of us will be vaccinated, then maybe we can really do face to face. So to ensure quality during this COVID, I think, pandemic, actually, our problem is about the activities in laboratories. We can't really do it, but we have software that we can use to do it. Just like in my case, actually, I'm enrolled in Harvard University, with EDX. I am learning, but the advantage with me is I already know about basics, the basics of engineering. Meaning I know how to use Raspberry Pi, how to program. I simply have to integrate the meaning I can learn it on my own. But in your case, for the senior high school, you still have to learn a lot. So maybe on the first semester in school year, we can really achieve what we want to deliver to the students. But hopefully on the second semester, we have to cope up with what we missed in the first semester. So siguro we can make adjustments. And just bear with us during this time. It's really a challenge. And maybe hopefully we can really meet face to face in our classes.
Thank you so much, Sir Randall, for that answer. Now we'll be having our last question. It will be for Engineer Maria Lea Flor de Castro for the Chemical Engineering Department. Ma'am Lea, the question is, what does the chemical engineering specifically offer? And what is the difference with chemical engineering, the other engineering courses, and BS chemistry?
Yes, good noon again. The first question is what do we offer in the chemical engineering program of Ateneo, where we have the new curriculum. Under the new curriculum, we have different tracks: the food and drugs manufacturing, environmental management, petrochemical engineering, energy engineering, biotechnology, and technopreneurship. But most of the research activities of our students and faculty members are now focusing on energy engineering and materials engineering. So those would be two of the strongest areas of specialization that we have. But we also work on the different chemical process industries because, as I have mentioned in my presentation earlier, there are actually a lot of industries that require, not only prefer, but actually require a chemical engineering in their processes, in their operations. So we wanted our students to be able to have a peek of the different industries where they will be working if they decide to do the industry path. Because as also mentioned, you can do the research path, the academic or the education path. You could also do the design work, wherein the chemical engineer will not be doing the operations work in the plant, but will actually be doing the design of the plant before operations. And then the second question was, ano yun, Kid? Kid.
The difference, ma'am, between the chemical engineering, other engineering courses, and BS chemistry, ma'am.
Okay, so one of the main confusions for students is BS chemistry versus BS chemical engineering, and those are actually very different courses. The chemistry the chemistry profession is more involved in the analysis and the analysis of materials. And also in quality analysis. But for the chemical engineering, it still is an engineering field. One of the confusion mainly is because its name is chemical, so it's nearer chemistry, but in reality, it's nearer engineering. It's like the family name of the profession is engineering. So it's the subjects that we offer are more closer to the engineering profession than the basic sciences, which is chemistry. Chemistry is a basic science, while chemical engineering is an applied science. So what we do is designing the factories, the operations, and it's bigger scale than what we have with chemistry. So if you are good in chemistry now, because I think some of the students who come to us, to enroll to us, are good in chemistry and math. So if you're good in chemistry and math, you have to also consider if you really wanted to be a chemist or a chemical engineer, because those two are very different professions. There are some activities that would interlap or would overlap, but ultimately they are very different professions. The chemical engineer is an engineer, and the chemist is more on the basic sciences and quality analysis.
Thank you so much, Engineer Maria Lea Flor de Castro, for the answers on the specific questions for the chemical engineering department. Okay, we can have one last question. Is it possible to take structural engineering after graduating in architecture po? Thank you. From Alexander Tabada. Architect Policarpio, Engineer Casares. Anyone can answer the question? The last question.
Sir Polly, are you there?
Yes. Hello.
Yes, sir,
Can you
Polly.
hear me?
Yes, sir. So the question, sir, is in the chat box. Is it possible to take structural engineering after graduating in architecture po?
No, I think it's you should be a graduate of civil engineering before you go into the structural engineering as structural engineer, because limited lang ang sa architecture is limited lang ang structure ang engineering courses. Okay, it's more on you should have to be an engineer first, civil engineer, before you can go to structure as a structural engineer. Okay, thank you.
Thank you so much for the answer, Architect Policarpio. So, learners and other participants, if you have more questions, we would post or we would share a screen later for you to contact us anytime via email, via the landline if you have more questions due to the interest of finishing on time. So, here's the email at engineeringarchi, ENGGARCHI at adu.edu.ph, or you can call at 082-221-2411, local 8313. We also have these cell phone numbers 0917-303-6037 and 0956-389-3829. Okay? So for now, we will now proceed to the closing remarks, which will be given to us by our very own Engineer Michael P. Barino, the moderator for the Robotics Club of the Senior High School, and also a faculty member of the Pre-EA of the Senior Ateneo de Davao University Senior High School. Sir Mike?
Hello everyone, good noon, brilliant minds. I'd like to thank everyone who take their time to attend in this webinar. Initially, we planned to have an exclusive event for 20 participants or less. But this opportunity to hear from Dr. Randel Spina, Dr. Renil Baroca, and the department heads of C themselves came 2 days ago. Sino nga ba yung tatanggin? So even now, I'm still surprised to witness again my respected professors while I was still in my undergrad, inspiring young minds to indulge in the world of engineering and architecture. Maybe inspire is such a deep word and perhaps an understatement. Naalala ko pa, ito yung mga profs na ko dati na nagpa-realize sa akin na ang grade na 75% is something to be proud of. Natanong ko rin minsan, bakit pa pahirapan kung pwede namang pumasa kami lahat. But when I took the board exam, when I started my junior engineering practice, and when I pursued the academe, nasabi ko, kaya pala. Now, these brilliant minds of these brilliant professors, along with the ADDU institution, did not only provide us the knowledge to become an engineer or architect, but also equipped us holistically to bring positive impact to ourselves, to our families, and to the community, especially here in Mindanao. Yes, hindi madali, pero worth it in the end. To all aspiring engineers and architects, know that I believe in your potential. And one day you will extend this belief as well to others who might need it too. Let us make our life count. Once again, with utmost gratitude, I sincerely give my thanks to first to God who sustained us and gave us purpose in this life, to ADDU's School of Engineering and Architecture team, to ADDU SHS Academic and Formation team, to all participants here in Zoom and in YouTube, and of course to my ADDU Robotics team who sacrificed their game time, lag time, and Netflix time to make this event possible. With all humility, I now close this webinar entitled The Lens of ADDU Robotics Engineering with an introduction to other engineering and architecture disciplines and Industry 4.0. Goodbye, ad majorem Dei Gloria.
Thank you so much, Engineer Michael P. Barino, for the closing remarks. Before we come to a close, we would just like to announce the winners of the hashtags game earlier. So we would like to congratulate the following learners. We have Renzo Malake, Denise, Armamento, and Kyle Cortez. So if you are one of the winners, then please do email your interest in claiming the prize to Engineer Montani. So for now, before we close this webinar, I would like to request everyone to turn on their cameras for a one last picture taking. Okay, technical team will take the picture, right? Ready? 1, 2, 3, smile. Okay, one more. 1, 2, 3, smile. Okay, that's it for today, everyone. So thank you so much for joining and participating in this ADDU School of Engineering Architecture and Senior High School Career Day. So again, if you have more questions and concerns and more inquiries, please do contact us. Thank you and have a good day.